Day 252 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing LeetCode problems daily, y'all. And today we have question number 127, word ladder. The difficulty level is hard, but don't you worry because we're going to keep the solution as simple and easy to understand for all levels of programmers. So let's get into it, y'all. A transformation sequence from word begin word to word end word using a dictionary word list is a sequence of words such that begin word goes to S1 and S1 turns into S2 and S2 turns into S3 all the way up until SK, right? Such that every adjacent pair of words differs by a single letter and every SI for one is less than I and I is or one is less than or equal to I and I is less than or equal to K in word list. Note that begin word does not need to be in word list. SK is equal to N word. Given two words, begin word and end word, and a dictionary word list, return the number of words in the shortest transformation sequence from begin word to end word, or 0 if no such sequence exists. So, it's a lot to kind of understand right there. So let's look at example 1 so we can see what they mean. In example 1, we have the input equals begin word equals a string hit, end word equals a string cog, and the word list is an array of strings hot, dot, dog, lot, log, and cog. The output is 5. Explanation says one shortest transformation sequence is hit, turns into hot, which turns into dot, which turns into dog, which turns into cog, which is 5 words long. So let's focus on this explanation right now so we could go through it and see what they mean, right? So they give us this word hit, this the begin word, right? So we come up here, we say now we have hit. We want the end word is cog, so we want to go from hit to cog. However, we can only change the word by a single letter at a time, right? So every adjacent pair of words differs by a single letter, right? So we have this word list right here. In this word list, we have all the words we need, or not that we may or may not have all the words we need in order to turn hit into cog by changing one letter at a time, right? So we start at hit, we could turn hit into hot, right? So we go boom, boom, turn that into hot. Hot is in the word list, so it's good money. We can use it. That's why hit turns into hot right here. Boom. Now we only changed a single letter. We changed this I into an O right here. We still have to get the cog. We're not there yet. We're still at hot, but we can keep going, right? Hot is in the word list, so it's good money. Let's keep going. Next, we can turn hot into dot. Boom. So we turn hot into dot. Now remember, we are only changing one letter at a time. This time we changed this H into this D. We're still going. We're still making moves. We're getting closer and closer to cog. Now you might wonder why we changed it to D when there's no D in cog. So what was the point of changing it to D? Well, we can only use letters that are in this word list, right? So, and we can only change one at a time. And in this case, we have to use dot just to get closer to cog. So as you can see, after we do dot, now we can do dog. Boom. Because we already added the D. So now we can do dog. Boom. Now we could turn this T into a G, right? Boom. So now we have hit, hot, dot, and dog, right? So now we're getting closer to cog. We only need one more letter to change, which is the C. Boom. So we changed that. Now we could change dog into cog. Now, remember, we have for every letter or every word after the begin word has to be included in this word list, right? Even the N word. The N word has to be included in the word list as well. As you can see, cog is included in the word list, which is why it's good, right? So that's why it's important to understand the sequence or how we are going to change these words and iterate through this word list to make sure that each word is in word list as well. So that's how we did that For example 1, that's how we got there, by changing one letter at a time. And each time we change the letter, it's important to remember that the word that after we change the letter, the word that it spells has to be in this word list. We can't just change one letter and then the word is not in the word list. It's not going to work like that, which is why we had to use dot to get the dog, just so we could get the cog, because dot is a word that's included in the word list. So it allowed us to get closer and closer to our goal, right? If say dot was not in the word list, right, and we didn't use dot, boom, how will we get from hot to dog, right? If dot is not there, there's no way for us to get to hot from hot to dog, because we would have to change two letters, H and T, to get the dog, and there would be no other way that we could do that. Maybe we could use lot, excuse me. There is another way. We could have used lot, but hey, it's okay. I think we use dog because of this sequence right here. I has to be less than or equal to K, and in this case, dot is uh, closer or less closer to the beginning of the index than lot. So I think that's why we chose dot over lot, because of its placement in the array, or its index in the array. Now, now that we understand the first example, let's look at the second example where we won't be as lucky and we won't be able to get to the end, right? So in input, in example 2, we have the input begin word equals hit, end word equals cog, the word list equals an array of strings, hot, dot, dog, lot, and log. The output is 0. Explanation says the end word cog is not in the word list, therefore it is no valid transformation sequence. So remember what I was saying, every word after the begin word has to be in this word list all the way up to the end word. So in example 1, the end word is cog. We have cog in the word list, so it's a valid transformation sequence. However, in example 2, the begin word is hit, the end word is cog, but cog is not included in the word list, and we have to use words that are in the word list to validate our transformation sequence. And since cog is not included in there and it's the end word, there's no way for us to validate our transformation sequence, so we have to just put the output as 0. Oh, and excuse me, y'all, going back to example 1, we didn't even talk about the output being 5. The output is 5 because it took 5 transformations to get to cog, right? First we had, including the begin word, we had hit, that's 1, hot, that's 2, dot, that's 3, dog, that's 4, and cog, that's 5. So after we find out the sequence, we're not done yet. We still have to count the words in that sequence, and that's what we're returning. We're returning the count of the words in the sequence, right? We're not returning the sequence itself, which is important to and understand. And I just want to make sure I remind y'all of that because I forgot to say it. Now that we understand the question, y'all, let's get into the solution. But before we get into the solution, y'all, if you need any new Apple AirPods, go ahead and check that link out in the description. And then after you do that, do not forget to like, comment, and subscribe, y'all. We're trying to run this engagement up, and your support is appreciated when it comes to that. Now, let's get into the fun part, the actual solution, y'all. We're going to be using a BFS with a B as in breath, a breath first search to do this. So let's get into it. Now, the first thing we need to do is we need to define the alphabet, which we will iterate through possible character replacements, right? That's what we're going to use it for when we are trying to figure out a character letter to replace another letter with. We're going to have to define the alphabet so they will know, the compiler will know where the letters are coming from. So in order to do that, we're just going to come out, excuse me, this should be outside the function, but in the class, we're just going to say private let alphabet, make sure my spelling right, set that equal to a string, and then it's going to be the alphabet, right? So we're going to say A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. Just like that. Boom. Now let's get into the function, right? Now First thing we need to do, we need to ensure that begin word and end word are the same length. Otherwise, we could just return 0, because if they're not the same length, then it's not going to work when we're trying to add word. We're going to have to add letters. We won't be able to, what's the word I'm looking for? Convert letters. We'd have to add letters when really we're just trying to turn one letter into another letter. We're not really trying to add any letters that weren't there, or add any extra letters, right? So the count should stay the same. So in order to do that, we're just going to say guard begin word dot count is equal sign end word dot count. Boom. And then we're going to say else, we could just return 0. Boom. Because if there's, once again, if there are extra letters, right, we wouldn't be turning I into O. Or say this word was hit and this word was just a cog with 2 G's, right? We would have to add a letter, not turn, it wouldn't be turn this T into a G. It would be add a letter, and that's not what we're trying to do. We're not adding any letters. We're just turning one letter into another letter. So boom. Now it's time we need to convert the word list into a set, which is going to just make it more efficient for us when we're doing lookups and removals, right? So we need to convert this word list into a set. This word list right here, we need to convert that into a set somehow. So in order to do that, we're just going to declare a variable. We're going to say, excuse me, y'all, we'll get this cleaned up for you. We're going to say var words equals, it's going to be a set, so less than string, a set of strings greater than, and then we're going to initialize it with word list, just like this. Open up the parentheses and put word list in there. Now we need to initialize our queue for our breadth first search, when we'll start with begin word and we'll start with the step count of 1. So in order to do that, we are just going to say var q, boom, colon, square brackets, open up the parentheses. We're going to say string, comma, int. We're going to set that equal to an array, or square brackets, open up the parentheses, begin word, comma, 1. Now this 1, remember, we have to return the count. So this 1 is just representing the count, right? And right now, the count would be just 1, right? Begin word is the only word in there, or that's where we're starting. That's the word we're starting with the count of 1. But remember, we're going to count all of the words just so we can get our output, all the words in the transformation sequence to get the output. But right now, we're going to start at 1 because of the begin word. Boom. Now let's get into the while loop. So we're going to say while exclamation point q dot is empty, which means while q is not empty. That's what the exclamation point means. Boom. So while exclamation point q is empty, open up the brackets. We're going to say let, open up the parentheses, word, comma, step. Step, once again, that's this 1. That's just what we're going to use for the count of the words. How many steps do we have to take? We're going to set that equal to q dot remove first. We're going to put parentheses. So we're going to dequeue the first word and its initial step count to start, right? Boom. So now, next we have to see if the current word matches the end word, and then if it does, we return the current step count, right? Or the count of how many words there are in the transformation sequence. So to do that, we're just going to say guard word does not, exclamation point, the exclamation point equals, so does not equal end word. Boom, end word, else we're just going to open up the brackets and return step. So while we're looping through these while we're looping through these words, Once we get to the end word, we know that we could stop and we could return a step, which will be how many words it took to get, or how many steps it took to get to the end word. Boom. Then after that, let's start our for loop. We're going to say for I and 0 up to word dot count. Open up the brackets. First thing we need to do is convert the current word into a character array so that we can modify it. So in order to do that, we're just going to say var chars for characters equals an array parentheses word. So once again, this is going to convert the word into an array so that we'll be able to work with it, or we'll be, so that we'll be able to mutate it better or change things, So boom. Now let's see. We're gonna start another for loop. We're gonna come down here. We're gonna say for ch and alphabet where ch exclamation point ch does not equal exclamation point equal chars square bracket I. We're going to open up the brackets, and we are going to replace the character at position I with a different character from the alphabet. So that's why we created this alphabet up here, so we know how to so we'll be able to replace characters at the respective position, right? So we're going to say chars square bracket I equals ch, just like that. Boom. Now we need to convert the modified character array back into the string. So we could just say let modified equal string parentheses chars. Boom. Now we need to see if the modified word is not in the word list, and if it is, we could skip this iteration, right? So we're gonna come down here. If it's not, we can skip it. So we're gonna say guard words dot contains, open up the parentheses, modified, else, open up the brackets. We could just say continue. Boom, just like that. Now we need to remove the modified word from the set to avoid revisiting it. So in order to do that, we're just going to come down here. We're going to say words dot remove, open up the parentheses, modified, just like that. Excuse me, y'all. Now we need to add or enqueue the modified word with an incremented step count, right? So we got to increment the step count every time we get to a new word. So in order to do that, we are just going to say q dot append, open up the parentheses, modified, comma, step plus equal, or just plus 1. Now, if all else fails and the queue is empty and the word was not reached, or so like if the queue was still empty or we didn't get to reach the end word because it wasn't in word list, we could just return 0. Boom. Now that should be all she wrote. Let's run it, see how it runs. Submit. Boom. Let's see. Okay. Cannot find end word and scope. So this W should be capital. So run it again. Might be some more errors with that. Let's see. Error cannot find N. Oh yeah, so this should be an integer. Sorry about that, y'all. Let's run it again. Let's see. Okay, instant method append expects a single parameter. So let's see what's going on here. So Q is a tuple, that seems right. Then Q, make sure I spelled everything right. Modified, comma, step plus 1. Let me see. Oh, hold on. That's the method of pen expects a single point. So now hold on, y'all. Oh, sorry about that, y'all. This is a tuple, so this should be a in parentheses. The modified step one should be in parentheses inside of the append parameter parentheses. So hopefully that fixes it. Now let's see. And it's accepted, y'all. So let's submit it. Make sure it stays accepted. Let's see, y'all. Let's see. Fingers crossed. And look at that, y'all. 222 milliseconds beats 56.11% of users with Swift, y'all. That's what I'm talking about. We're not going to worry about too much about the numbers right now. Right now, we're just worried about being able to solve the solution or solve a problem that's presented in front of us. And with this, I feel like this is a good solution for that because as we're learning, we want to be able to understand what we're learning, because if we don't understand it, then we probably didn't learn anything. So I feel like this is a good solution for that. So get one more look at the code, y'all. One more look at the code. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.